So next one is gate current. The same electrons which are responsible for substrate current or can actually cause gate current. So the hot electrons, because of the impact ionization, so they can also produce gate current. We have already told in the beginning, gate resistance is infinity. So ideally, the gate current in a MOSFET is zero. But because of these process, there can be a very, very small amount of gate current which is flowing through your device. So this charge comprising of this gate current can be trapped in the oxide region, causing upward threshold shift in NMOS and reduction in PMOS. Because of this gate current, what is the issue? Threshold voltage will increase for NMOS, whereas threshold voltage will reduce for PMOS. This happens because of the gate current. All these are possibilities. You cannot say that always a device will have gate current, always the device will have substrate current. No. Depending on the operating conditions of the device, these parameters can be present or completely absent. And these have to be considered, and you cannot ignore them because it will create a question mark on the long-term reliability of the device. So we cannot ignore the effect of gate current and substrate current, and due importance have to be given while fabricating the device. Channel length modulation. So it is similar to what you have early effect in bipolar transistors. In the reverse biased PN junction layer, the depletion region will increase in the reverse bias. So because of voltage, your channel length is getting modulated. Channel length is getting changed. So that is called a channel length modulation. So the concept of channel length modulation is same as what you studied in BJT. So as the VDS increases, the extent of depletion region near the drain also increases. Thereby, the effective channel length will reduce. See, modulation, you use the term modulation where if something is varying, a channel length is being varied with respect to the applied voltage. As I'm going to increase my VDS, the depletion region size will also increase, which will reduce effectively the size of your channel. So drain current therefore increases with increasing VDS, and this effect yields a non-zero conductance. The effective early voltages in MOSFETs tend to be substantially smaller than in BJT. In BJT, the effect is more pronounced because you have working all the terminals, base, collector and emitter are all having their respective voltages and current. But in MOSFET, effectively the drain, there is no drain current, gate current in MOSFET is assumed to be zero, right? So whatever early effective voltage you have in BJT, you will not have such a high voltage in MOSFET. It will be comparatively very, very small compared to BJTs. So you can also increase the early voltage by using long channels. So that can significantly increase the early voltage in your MOSFET. So by using long channel devices, I can increase the early voltage which is available in the